This is a technology prototype that I worked on for a few months to investigate if cooperative games using big crowds of NPCs are possible on Roblox. This is not a game, it doesn't have actual art, level design, no weapon balance, no missions, and so on. The goal was to prototype main systems, check limitations, for example bandwidth, client and server performance, ability to control behaviors, and so on. So far everything looks doable. The demo uses 600 objects, it runs fine on my laptop and on my Android phone, even on cellular connections. The next step is to figure out game design. I'm thinking about fighting hordes of zombies with possibly a meta game of picking up fights in some kind of big semi-persistent universe, but it can also be 1000 NPCs storming a castle, and I'm open to ideas. There are 5 main systems. Object creation, state and movement replication, object pathfinding, object collision detection, objects AI system, and weapon system used for both players and objects. Object creation, state and movement replication. Each object is represented by a small data structure that has a unique ID, a small integer, character type, X and Z for position, direction angle, health, and some AI and pathfinding data. Only clients have actual instances. Currently there are 6, but it can be anything. No humanoids, just model body parts. Server logic runs at kind of fixed 20 Hz ticks. The map is covered by a grid. Each tick, object ID, X and Z position, direction angle, and state for object within each grid are compressed into a low buffer. Grid data is sent to each client based on how close the client is to a specific grid, with more distant grids receiving data less frequently. Unreliable events are used. On the client side, each object has a buffer for a number of received tick data. Based on estimate of how far the client is behind the server, the client uses interpolation, extrapolation, or dead reckoning to compute XZ position and direction. Using a raycast to get each object height above the ground is expensive, so I use a pre-computed height map instead. Some state changes, for example health and some combat-related data, are sent separately as needed using reliable events. Pathfinding. The map is split into convex areas. Paths between edges of areas are pre-computed offline, compressed, and stored in data store. At runtime, a server script figures out what areas of the map, object and the goal are, finds the best path between a few possible neighbor edges, does some optimizations for specific cases. For example, for path between neighbor areas, path within certain distance, and so on. A path is a sequence of points on some area edges. As object moves, it checks for crossing the edges. The goal is often one of the players. If player moved far enough, crossed to another area, the path can be recomputed or adjusted. Within some distance to the goal, there are direct line checks. The walls of the environment are in spatial grid, as there are quick segment versus walls check. Other object or players can push an object somewhat off the planned path. Usually it's corrected by trying to move to the next check edge. There is specific logic for sliding along edges. If an object hits walls and moves along the walls for too long, so it's slightly off path, the path can be recomputed. Small props or obstacles are assumed to be covered by predefined convex polyhedra, so objects mostly slide along while moving on their path. There is internal queue for pathfinding requests so that the system can be throttled. This is mostly a prototype and some things need to be improved, but that will have to be based on actual game design. For example, support for dynamic edges like breaking doors, opening gates can be added. Collision detection. Objects do not have can collide and do not even exist in a server. So without some kind of collision or repelling forces between them, many objects would just collapse into the same spots. To prevent this, objects and players push each other away. Each tick, the server computes average pushing force using a spatial grid of objects and players. The same system also allows players to push objects out of the way. On the client, there is also a player slowdown when player is pushing against the crowd or surrounded by the crowd, and some heuristic to slow down when trying to jump out of the crowd. When an object approaches a player for a melee attack, the pushing force would be working against it. So in such cases, we reduce pushing in between specific player and specific object for the duration of the attack. On the client, object body parts can query for weapon raycast checks. So far, this is not causing performance issues. Basic AI system. Each object has a current state, for example, idle, moving to the goal, attacking, and so on. The logic mostly runs on a server, but parts of the logic for objects attacking a specific player run on this player's client. This minimizes latency and probably okay for cooperative games. Object detects and remembers players within some radius, kind of like the audio sensor, and within a cone, kind of like a vision sensor. It also remembers damage done by players. Those factors are weighted when a new goal, that is what player to attack, is selected. If there is no goal, object will stay idle and sometimes move around. There is a memory degradation with time, so an object would forget if player was out of sensor range for a while. If an object is attacking one player and another player deals enough damage, object can switch to attack this player. Right now there are three types of objects. Green, with a melee weapon, it tries to come close and attack. Yellow, with that shoot arrows, when it's shooting within a shooting range, or comes close and does a melee attack when closer. It's a bit slower. Red explodes a bomb that kills other objects and can cause chain reaction. That's the fastest. Killing those red enemies while they're in the crowd is a way to score a lot of kills. Weapons system. It supports hit scan, projectile, and melee weapons, and some special weapons like flamethrower or chainsaw. Supports weapons with multiple bullets, weapons with area of effect damage, supports once on hit or kind of continuous over time damage application. For players, the system detects the hit on the client so that the player shoots at exactly what it sees. Hit info is passed to the server that can do some validation in the future. The server decides if and how much damage to apply. New health and some hit data passed to all clients so that they can show effects, play animations, audio, and so on. For objects attacking a specific player, the hit is also detected on the client, but can be verified on a server. The damage applied on a server. This doesn't provide the best security, but this is for cooperative games and works well even with a significant lag. For some less precise and not instant weapons like a flamethrower, affected objects are determined on the server. There are several additional systems. Object spawners. A server script, usually it's a mission script, calls functions to define where, for example, spawner name, position, radius, to spawn objects, what type of objects to spawn, how many, and over what period of time. The spawner system works within the maximum total number of objects in the world. When the number of objects is below maximum, it proportionally distributes available spawns across active spawners. Debris system. When object is killed, it can produce debris, body parts. The debris system clears them after a while. Unlike Roblox built-in debris, it keeps a number of debris within a given maximum and supports debris priorities. For example, torsos can produce debris even when the total number is higher, so there is often at least something, while limbs might not produce debris if the total number is high. Before the debris system, killing a lot of objects at the same time caused client spikes in physics. Missions. For now, a simple script that can be set up for each mission. Currently, it only sets up initial spawners and sets up some spawners in a while. Audio system. There is ambient audio and audio for weapons and other game events. For the ambient, I compute on the client the number of objects in a distant disk around the player and also in a closer disk. The system uses some logic to start up to some number of distant and mid-range sounds. More sleepy, growling kind of sounds for distant and more aggressive for mid. The other sounds are for death and weapons. Animation system. A very simple system to run idle, run, attack, damage animations with some priorities. Each client runs animation via animation controller when the object state that it receives from a server changes, for example from idle to moving to a goal. Effects system. A basic system to have placeholder weapon effects. Mostly particle effects with some beams for trails. Effects can specify lifetime, some parameter overrides, for example for emitters, so that the same kind of effect template can be reused for different actual effects. There is a layer that uses hit material and weapon type to figure out what effects to run, but it's basically unused in this prototype. Effects can optionally be bundled with some audio, can be welded to another object part. UI system. A basic system for defining sets of buttons with callbacks. Be able to add, remove such buttons, for example, when adding and removing a weapon. Buttons can have some basic animations of color and so on, but it's not used in the demo. Support for defining different maps. There is like a simple map definition system, so that each map can define size, dimensions of various grids, maximum number of objects, where players spawn, positions are, and so on. Leaderboards and teams. It counts kills and deaths using a Roblox leaderboard system, and there is a support for teams. A player can belong to a team, so that can be optional friendly fire. It's not used in the demo. Player spawns. Each map defines a set of player spawn locations. When a player dies, the code selects the spawn point with fewest enemies nearby, but there is a per spawner defined bias to affect this. Plugin. I wrote a studio plugin to help edit pathfinding areas, visualize a walk map. Walk map and some navigation data are pre-computed per map and stored in data store. I'm using low buffers and some basic compression tricks. Walk map visualization uses Dynamic Mesh API. They are loaded on a server when the game starts. A walk map is also passed to the client. Things not in the demo. I use the same code base that I used for several other prototypes, so there are pre-existing systems not used in this demo. Resources. Pure player resources with ability to define the resource UI, collect and drop in-world pickups, and use resources to create buildings. Resource spawners. Buildings that spawn resources of given type, for example wood or specific weapon that can be picked up by players. Destructible props. Props taking damage and change into different damage destroyed states. Beginning of a server-side bot system. Bots can do basic navigation using Roblox built-in navigation in separate loose threads. Can hold weapons, drop weapons or resources, can belong to different teams, but they cannot really do actual combat. Third-party software used. I use a camera system and a commander system for debug console. Hit F2 on desktop or debug buttons on the top right. It allows turning on and off God mode, AI, and so on.